Okay, and the first presentation is by Marek Wiewiórka, who is a chief data architect in Getting Data. He has over 15 years of experience in designing modern data and MLOps platforms. And Marek, the floor is yours.
Hello. Oh, great. Hello, everyone. Once again, thanks for having me today. Especially, I would like to thank Agnieszka, who invited me personally to this meetup, to this presentation. The topic on today's presentation is portable and cloud-agnostic MLOps platform with Kedro, MLflow, and Terraform. And during this short presentation, I would like to tell you a few words how we as Getting Data approach designing and implementing MLOps platform using those three technologies. Maybe I just quickly introduce myself. So as I already Agnieszka said, I'm a chief data architect at Getting Data. Apart from that, I'm also a research assistant at Warsaw University of Technology. And in my spare time, I'm a contributor to a few open source projects, including Snowflake Terraform provider, Sekira, which is what was part of my PhD thesis, a tool for analysis of data from genomic sequencing, and Kedro, because also Kedro is some part of this presentation. And personally, also, I'm a long distance runner and gravel bike enthusiast. Equally, just one slide about Getting Data for those who haven't chance to work with us. So we are more than 100 big data consultant, and we got like three main areas of expertise, namely MLOps and modern data platforms, ML engineering, and stream processing, which is really worth emphasizing because stream processing and real-time analytics are our key differentiators. We work with a number of technologies. We try to combine open source ones with managed services. As I said, we are also, as Getting Data, active contributors to a number of open source projects, including MLflow, Airflow, OpenLineage, or Apache Flink. You must have heard about MDP abbreviation, which is translated into modern data platforms. But we at Getting Data do believe that it should be should stand for MLOps enabled data platform, because we observe that nowadays most of the offering, including, for example, Databricks of Snowflake or other cloud providers, try to bring back or bring advanced analytics, machine learning, and MLOps closer to the data. This is why we do believe that this kind of offering, this kind of capabilities should be available to all of, once you deploy a data platform, it should be available straight away. Since this is a MLOps community, you all are aware what MLOps is, but I would just try to highlight some of the ways people understand MLOps, because there is no like a single definition of that. Some believe that it's actually application of DevOps principles to ML world. Some claim that some people claim that it's about managing machine learning model lifecycle. Maybe it's about tools and platforms, about automation, also about infrastructure. And all these statements are, of course, correct. But I personally believe that the ultimate goal of MLOps platforms is productivity. This is why we coined a kind of productivity manifesto, which is very, kind of like agile manifesto or DevOps manifesto, where we put a few statements that are very close to our hearts. And First of all, as I already mentioned in the intro, so we do believe that machine learning and data science should be a first-class citizen of modern data platforms, because this kind of activities should be available to everyone. It's also, in our understanding, is a way of democratizing access to the data, to the predictions, to some advanced analytics things. Later on, we also are adhere to open standards and cloud agnosticism. So we really believe that MLOps tooling and MLOps platforms should be based or built upon open standards, open technologies, which of course can be then later on mixed with some cloud offering, but no means it should be in a way any kind of vendor locking possible. Then we are really fans of like fast small projects, bootstrapping and standardization, because we think that is the key factor of for organization to adopt MLOps principles and ML at all. And finally, we really think that there should be this decoupling of execution environment and pipelines definitions. This is what we understand by that is when you, as a data scientist or ML engineer, implement a training pipeline, you shouldn't care about the underlying infrastructure, underlying API of the, for example, ML offering of the cloud providers. And as a bottom line, we really tend to implement MLOps platform in that way, that it's always provisioned within days, not months, because we already come with some predefined and ready components for that I'm going to discuss in details just now. ML projects can be considered from at least two different perspectives. One is the perspective of data scientist, which is more about experimentation, exploratory data analysis, maybe using some machine learning frameworks. But there's also another perspective of MLOps or ML engineers that are more about execution environment, about infrastructure, about security or accessing the data. And there is a need for an in-between layer, which we called GID MLOps platform. So there is a layer that bridges the gap between these two different perspectives, these two different set of peoples and skills at the same time. We tend to implement our MLOps platform using, or we based our MLOps platforms based on three pillars or three main components. One of this is portable MLOps framework, which in our case is Kedro. Then goes experiment tracking and collaboration. For this purpose, we use MLflow. And for infrastructure as a code, so provisioning the required resources, we of course use, maybe not of course, but we use Terraform. There is yet another component depicted on this diagram, which is the cloud integrations, which we also cover, and I'm going to discuss this in the later phase of this presentation. Maybe I'm not going to go into details about MLflow and Terraform, because these two things are very popular among MLOps practitioners, but I'm going to highlight some of the core features of Kedro framework. Maybe before doing that, how many of you already have used Kedro before or heard about Kedro? Oh, amazing! So there is quite many people that already are familiar. But did you just tried it out, or maybe you also implemented some production-ready projects using Kedro? Both. Okay. So we definitely should exchange some experiences after the presentation. But nevertheless, I'm going to highlight some of the features of the Kedro, and then later on, I'll also discuss of our contributors as getting data to Kedro. So for those who haven't yet played with or implemented anything with Kedro, so Kedro is an MLOps open source Python-based framework, which was initially developed by Quantum Block that was later acquired by McKinsey. But still, Kedro is as I said, is an open source project and is part of Linux Foundation in the area of ML and AI. And the core idea behind Kedro is to bring back the good engineering practices to the ML world, because we are all aware that ML workflows or ML projects suffer from the lack of the engineering sometimes, because the core interest of people that are doing advanced analytics are rather towards modeling, figure out the best prediction, not really about the way it should be implemented or deployed into the production environment, or even about the machine learning life cycle. So Kedro is one of the most popular MLOps framework that tries to address this problem. And we as Getting Data and Marcin Zabłocki in particular, we are supporters and contributors to Kedro, and Marcin is even a member of the Kedro Technical Steering Committee. Right now I'm going to just highlight or touch base on some core Kedro features. The first of all is the Kedro starter or Kedro templates, because it's in most of the cases is the first place when you have some contact with MLOps or MLOps projects or machine learning projects. So Kedro comes with a concept of Kedro starter, which is in fact a cookie cutter template. This is something that is aimed at standardization of projects within your organization, so machine learning projects. So you can define using this templating mechanism a set of predefined templates, which later on can be used when developing new projects. And by doing so, members of your organization use the same template, the same way of defining your machine learning code. And this is why it does, of course, is good for the collaboration and also switching the projects and also contribution between the teams. So this is very easy to define, like a set of templates, set of starters that can be, for example, targeted different technologies. For example, can be starter for PySpark-based pipelines or Snowflake-based or some other technologies, which later on can be reused among different projects. And the second core feature is the very lightweight abstraction of nodes and pipelines, because in Kedro nodes are just like Python functions, which can be easily connected with each other and exchanging data between each other. But this abstraction is really lightweight, but still it gives us the possibility to abstract the underlying runtime environment, because in each of the cases, no matter what runtime environment or execution environment you use, you can use the same way of implementing or defining your machine learning pipelines. This is what I actually just mentioned. So as you can see, here we got the way we define pipelines using Kedro nodes. And nodes, in fact, is just a pointer in quotation mark to a Python function. We also define some input and outputs of the function, and based on this kind of definition, Kedro design or the runtime define a proper DAG. So and the way the code is later on executed. As you can see, a node is just like a regular Python function that has some inputs and outputs. So there is no black magic there. It's really lightweight abstraction. Of course, we have also a way to implement input parameters for our nodes of the Kedro node, of the Kedro pipeline. And these parameters, as you can see, are just like highlighted here, but the definition or the proper value of these parameters are stored in a separate directory, separate configuration directory. And here we got yet another very cool thing about Kedro, apart from like a separation of parameters and data between the code. So here we got a concept of environment, because you can see that here, for example, have at least two environments by default, which is base and local. You can define a number of other runtime environments. And by doing so, you got a clear separation between your pipeline logic and some additional configuration values that are kept separately, are not hard-coded, and then you just need to, in the runtime, define the execution environment, and Kedro automatically will pick up the right set of parameters and also data. If we are talking about data, Kedro comes also with a concept of data catalog, which is a really cool way of defining the way you access your data, and together with the concept of environments, you can very easily define different ways of reading your data, depending on whether you are doing some analysis running on your local machine or some dev environment, and for example, a production environment. So you can here, if you take a closer look at this slide, you got the data catalog defined twice. One is for your local development environment, the other one is targeted for cloud environment. As you can see, for example, the same data set companies, which is referenced in your code, in your pipelines as an input or output, has two definitions. So in the local catalog, you are using Pandas API for accessing the data that is stored locally under some path on your hard drive. Whereas in the cloud environment, you got the same definition, but this time you are referencing a data set that is stored somewhere on your object storage, for example, on Azure or, for example, GCP one. And by using that, you can very easily move your pipelines between environments by just like specifying a different runtime environments. And Kedro will pick up both parameters, some additional values about, for example, how it should be logged, but also, which is very important, the way it should access the data set that are required by your pipeline. There is a lot more of Kedro features, but two are also worth mentioning, especially. This is the modular and dynamic pipelines. So by using this concept, you can reuse some part of your pipeline among different, you can use make a kind of pipeline template, and then reuse it between your implementation. And also you can use some dynamics in the way the pipeline is generated. And we just prepared a blog post about it, so we can stay tuned, and we should release this and publish this blog post very soon, so you can learn more about it. There is, of course, a lot of more integration with Docker, Spark, Airflow, and so on and so on. But you can easily navigate to Kedro documentation and grasp the information. But the question is whether we are done yet. And if you remember about our diagram, there is yet another rectangle, cloud integrations. This is actually very, very cool stuff that we as Getting Data are especially proud of, because we did a lot of contributions to this part. So as an intro, as a very quick intro, if you already played a bit with ML or MLOps offering of the cloud providers, you must have noticed that for each of the underlying cloud providers, you need to target your code specifically, because the API are not compatible. There is no open standard for interacting with these services. So if you, for example, write your pipeline to run on Azure ML or Snowflake or Vertex AI or SageMaker, you always need to put all these specific API calls into your pipeline. So in that way, this pipeline is not portable by definition. What we try to achieve with Kedro and set of plugins that we develop is that you just need to define your pipeline using Kedro pipeline abstraction, pipeline node abstraction, and there by a means of set of plugins, runtime plugins, this code automatically is translated into API of the cloud vendor or a platform of choice, either Azure or Vertex and so on. This is why we try to sell or like call Kedro as a kind of Terraform for machine learning pipelines, because we use like a one single way of defining this using a single API, and thereby set of providers, plugins, whatever you call it, your code would be translated into a specific native API of a specific cloud provider. We already have developed a few such providers, such plugins for Vertex AI, for SageMaker, for Kedro Kubeflow, Azure ML, and recently also for Snowflake. So, for example, if you are working in a hybrid environment, you may, for example, use Kedro to write through pipelines for Kubeflow pipelines that are deployed on your local on-premise Kubernetes cluster. And if you, for example, at the same time are on a GCP cloud, you can use the Vertex AI for defining your pipelines. And each time you just needed to use Kedro and then just specify a runtime environment and runtime plugin that translates your code into the native API calls on the underlying cloud service. We are also working on Kedro Databricks integration, so also stay tuned for that. Okay, so maybe I will just quickly, using Kedro Snowflake as an example, explain how does it work and what are the possible integrations and the way we can implement MLOps using Kedro and, for example, Snowflake. But in many cases, most of these things apply also to other platforms, because the logic, the idea is very, very the same. So in case of Snowflake, we of course define our pipeline using Kedro. There is this step of ML pipeline translation. This is covered by our Kedro Snowflake plugin, which is the plugin. The pipeline is translated into some native mechanism of the platform. In case of Snowflake, these are tasks or DAG of tasks. In case of Snowflake, we also cover using a set of Terraform modules the integration between external experiment tracking and model registry, which in our case is MLflow. So there is API integration and storage integration in order to exchange both the parameters metrics for experiment tracking as well as logging the final models. And once the model is registered in the Snowflake, it can be easily deployed either as a UDF inside of Snowflake or as a REST API using, for example, some other third-party offering like SageMaker or Vertex AI endpoints. So in case of Snowflake, we also natively support Snowflake ML. We also use MLflow Snowflake for deploying the model as a UDF. And depending on whether you are using AWS or some other cloud providers, you can also use the native endpoints mechanism, which exists on all cloud providers. And for this specific plugin, we also develop a built-in starter, which makes it very easy to start up. And this also applies to all of our plugins because we implement it in the same way. And there is, of course, a set of Terraform modules that do some additional stuff. Like, for example, in case of Snowflake, is additional code needed for integration with the external service, because by definition, by default, in case of Snowflake, it's not possible to directly exchange information between your instance of Snowflake and some external services. You need API gateway for that. For example, if you would like to have external MLflow service running as a container on Kubernetes or some managed service, you need to proxy your traffic through an API gateway that is available on all cloud providers. This is, for example, the case of GCP. In order for doing so, we also needed to develop a kind of request and response translators, because the existing mechanism of external functions that we use for the purpose of communication between Snowflake instance and external service like MLflow requires some changing the schema of the information. And for this purpose, Snowflake provides you with request and response translators like we got here, for example, to somehow shape the REST call properly. We also now developed or contributed a PR for Snowflake provider in order to make it possible. In case of AWS and Azure, there are some recent features that were introduced by Snowflake called external integrations. And in such a situation, there is no need to use this API gateway because you can define some network rules that makes it possible to define some external services to be reachable from inside of the Snowflake instance. So what happens later on? So you see that this is on the left-hand side, you got Kedro pipeline, and by our, which is later on translated by our Kedro Snowflake into a set of native Snowflake tasks, which now have some dependencies, and then it's resolved into a kind of very simple DAG. And in order to run your DAG inside or write your ML pipeline, Kedro pipeline inside of Snowflake, you just need to type one command that I'm going to show you during the demo. We also support datasets, Snowflake datasets, so both tables and also stages, which are kind of like internal object storage for exchanging data powered by AWS S3 or GCP, GCS or Azure Blob Storage. And we also do it for other plugins, which I'm going to show you as well. For example, this is just like for your reference. I'm not going to discuss it very broadly, but we also have a similar integration for Azure ML, which also integrates with MLflow, because Azure ML offering has built-in MLflow compatible service, so we easily integrate with that one as well. And again, we got a set of Terraform modules that make it possible to deploy all this orchestration around that very easily. Again, we got integration with native Azure ML datasets, so very similar to the one we got for Snowflake. And we also, of course, are providing a set of Terraform modules that make it easy to define the CI/CD processes, makes it easy to integrate and provision the MLflow services, as well, finally, for example, deploy this trained model to an online endpoint. And thanks to using managed endpoints in Azure ML, I got, of course, for example, technical monitoring out of box available. And now I'm going to show you a very quick demo, because there should be some interactive part as well. No, it's not like a live demo, because I pre-recorded it, and hopefully it will work. So this demo will show you how to, like in 4 minutes, interact with our Kedro Snowflake plugin. So we are starting with bootstrapping new projects based on our Snowflake starter. Then you got some wizard when you specify some basic configuration stuff. And then the code structure is generated. You need to only do some configuration around MLflow integration or your Snowflake instance. You got also generated automatically some very basic data catalog to just show you how to work with Snowflake table dataset and Snowflake stage file dataset. And once we got everything configured, we can just run it and see what happens. So as you see, we just type Kedro Snowflake run, and then what's happening behind the scene, and the Snowflake data warehouse, virtual warehouse is provisioned, and Kedro pipeline is translated into a set of or DAG of Snowflake tasks. And the tasks are executed one by one. First, you start with some parent task, then the MLflow experiment is started. So there is this integration between MLflow and Snowflake. So it starts with just logging some parameters. In the meantime, some others tasks have already completed. Behind the scenes, they are translated into the Snowpark code, because it's also possible to use. So some of our functions are Snowpark based. So you can see that these functions are automatically translated into Snowflake tasks. So once the pipeline is finished, we can take a look at MLflow again. So we see that pipeline is marked as completed successfully. So we got both parameters and some performance metrics logged into the MLflow from within the MLflow instance, as well as the final model with some signature that is required for inference. So our model is already registered or logged into MLflow, and then we can try to deploy it. First of all, we are going to deploy it using Snowflake MLflow plugin as a Snowflake UDF, which is then accessible from SQL as a simple UDF function. Here we got like inference for two records. And of course, we can also expose our model as a REST endpoint using some built-in Snowflake plugins, like for example, Snowflake SageMaker or Vertex AI or some other one. In this case, we are just expose it locally. And then we can, of course, easily access it using a very simple API call and achieve, of course, the same results as running it inside of Snowflake as UDF. So if we navigate to the tasks in Snowflake UI, we can verify that our pipeline is correctly translated into a set of tasks within Snowflake. We can, of course, take a look at the status of each of the tasks and verify some logs if there are some errors. Okay. Let me just quickly come back to the presentation. So if you would like to try out each of our plugins, you can just navigate to respective GitHub repository. In case of Snowflake, it's just Kedro Snowflake under our organizational GitHub. And in 3 steps, you can just have it up and running locally to access your Snowflake instance. Oops. Sorry. Summing up, I would like to leave you with three take-home messages. So in our opinion, Kedro is one of the best MLOps framework. It's not by no means it's the only one. There are some alternatives. We are aware of that. But in our opinion, it's one of the best, and we really offer that to our customers. We as Getting Data already made some contributions to Kedro, in particular to a set of Kedro plugins that makes it possible to deploy your pipelines to a number of managed services, which make your pipelines really portable. And we also use some other tooling like MLflow for experiment tracking and Terraform for infrastructure provisioning as two remaining building blocks of our MLOps platform. This of course was possible thanks to hard work of our of my colleagues. I would like to thank them here, in particular Michał, Marcin, and Artur, who are part of our internal MLOps labs on Getting Data. And you would like to learn more about some big data stuff, some cloud news, you can just subscribe to our newsletter and stay tuned for some updates, not only about Kedro, but also other things that we do in a big data and cloud community. Thank you.
Thank you, Marek. So now it's a question time. If you have any questions, raise your hand.
All right, so quick question, because I'm not sure if I got it right, but in essence, those plugins allows us to write the code in Kedro, for example, locally, and then if I want to deploy the code, those plugins allow me to automatically translate, for example, to Azure Data Factory or to Databricks, right? This is like the main thing. But in order to actually provision this data and to deploy it, I need to provide the infrastructure either by Terraform modules or to or create it from the scratch. Or are there any cookbooks, for example, in those plugins?
So in particular, these managed services, these are kind of managed services in many cases, so you don't need to provision these resources up front, because you, for example, specify some details of the infrastructure in the configuration part of the pipelines. For example, that specific node should be run on a specific flavor of VM or stuff like this. But indeed, many times you need, for example, to set up some security for example, your projects on GCP or Azure, to set up some CI/CD, to set up some data sets, some policies and stuff like this. And this is indeed done via Terraform. Yeah, you can use it, of course, separately without Terraform. You can provision that in using other ways. But in particular, these plugins are only about translating your ML pipeline into a corresponding ML service provided by GCP, AWS, Azure, or other vendors.
Okay, cool stuff. Thank you.
Thank you.
Any more questions?
Hi, I like the demonstration you made, specifically what he was talking about, the translating into using the APIs. My question is, what are some of the edge cases you guys came about?
Edge cases, you mean that in some cases
Limitations.
Limitations. So of course, this everything is under like active development. For example, in case of Azure ML, we got already 3 companies that are contributing to this project as well. So of course there are some here and there some errors, some issues, but we try to really address them very quickly. Plus these guys are really doing great job contributing to this plugin actually every week. So there are no built-in limitations, but of course this API are evolving. So there are also some things that are changing over time, and we are also adding some features. But no, there are no built-in limitations per se.
Okay. Thank you.
Do we have any more questions?
Hi, really nice presentation. Thank you for that. I have
Thank
a
you.
question about how you feel about the Snowflake integration. How do you feel about the costs? How do you feel about the performance and the rigidity about the package selection? Because from our experience, I'm from Allegro Py personally. We've seen that spinning up some batch runtime with the model and performing scoring on some batch runtime is much cheaper than actually doing that in Snowflake. So what are your feelings about that?
That's true. For example, our customers also, some of them prefer to run some heavy processing outside of Snowflake. But actually, Snowflake is really also a great job to like optimizing their warehouses. For example, there are some warehouses dedicated to ML workload. Plus, they are also, as far as I heard, they are also working about some other pricing for that kind of workloads based on the selection of your data, these virtual warehouses. But still, we think that there are different use cases. For example, there are some customers, some smaller ones, that would like to, for example, run everything inside of Snowflake because they would like avoid some dependencies of external orchestrators, some doing some hardening of their service and provision, playing with some security, advanced security. They, for example, prefer to run everything inside of like a very secure environment, very close to the data. Plus, thanks to the Snowpark, for example, they can very easily run some advanced processing or feature engineering. So it strongly depends. I wouldn't say that this is for everyone. If you are really maybe would like to optimize your costs, there are some other options. This is why we also like make it possible to run it on different infrastructure. That is also one of our idea of making it easy to deploy everywhere, not only without Snowflake or some other, but you, for example, can run it on your Kubernetes cluster using this plugin for Kubeflow pipelines.
Okay, thank you very much.
Thanks.